Good morning. I am Devasena. In this lecture, we are going to discuss about CS protocol architecture on IO interface in UTRAN logical interfaces. This topic is present in the subject wireless networks. 3G network architecture model is shown below. In this model, we have a mobile station and radio access network, core network. In the radio access network, we have node 1, node 2. That is, nodes are considered to be the user equipment. And we will be having a RNC, that is radio network controller. This radio network controller is connected to the core network in two ways. That is, in two domains it is being connected. One domain is a circuit switch domain and the another domain is a packet switch domain. In the circuit switch domain, we have mobile switching center block and gateway mobile switching center block. This circuit switch domain is connected to circuit switched network, and in the packet switch domain we will be having SGSN, that is service GPRS support node, and GGSN, that is gateway GPRS support node. This packet switch domain is connected to IMS, that is IP multimedia system, and from that it is being connected to IP network. This is being represented in this diagram. Here is a representation of 3G UMTS. In this 3G UMTS, we have three segments. They are user equipment segment, radio access network segment, and core network segment. The user equipment components are indicated here. One is for voice only, other is for data and voice. If the computer is interconnected with the headphone, means can be used for data and voice, and if the computer or laptop is connected only to the network, means it is used for data. This is represented in the user equipment segment. And in the radio access network, we will be having the interfaces between the user equipment and the core network domain. The core network domain may be of two domains. One is a circuit switched domain and the another one is packet switched domain. The circuit switched domain is connected to the public telephone network, the ordinary mobile phone, and in the packet switched domain network it is being connected to the packet data network, that is internet. This is indicated in this diagram. Circuit switched domain protocols representation is here. In the further slides, we will discuss in detail about these blocks in individual. Circuit switched domain supports circuit switched services like voice and fax. It can also provide intelligent services such as voicemail and free phone. The circuit switched elements of the UMTS core network architecture include the following network entities. One is mobile switching center. This is essentially the same as that within GSM, and it manages the circuit switched calls underway, and gateway MSC, that is GMSC. This is effectively the interface to the external networks. Here is a representation of mobile switching center MSC and gateway mobile switching center GMSC representation. In this diagram, we have mobile station. These mobile stations are connected to the base transceiver station through UM, that is air interface. This base transceiver stations are connected to the base switching center through ABIS interface. This base switching center is being connected to the mobile switching center. The mobile switching center is connected to the GMSC as well as to the EIR, that is Equipment Identity Register, as well as to the VLR, that is Visitor Location Register. The Visitor Location Register is in turn connected to the HLR, that is Home Location Register. The Home Location Register is in turn connection to the Authentication Center. This HLR is being connected to the GMSC, that is Gateway Mobile Switching Center. Finally, the GMSC, that is the Gateway Mobile Switching Center, is being connected to the PSTN, that is Public Switched Telephone Network. This covers the circuit switched domain network that is available in the 3G UMTS circuit. Here is another representation of BSS MSC. BSS comprises of BTS. BTS is connected to BSC. BSS means base station subsystem. BTS means base transceiver station. BSC means base station controller. This base station controllers is having a link to MSC, that is Mobile Switching Center. In the Mobile Switching Center, we have EIR, Equipment Identity Register, HLR, Home Location Register, AUC, Authentication Register, VLR, Visitor Location Register. This is indicated in the diagram. IU interface CS protocol architecture is shown below. That is circuit switched domain protocol architecture is indicated here. This protocol architecture comprises of three planes. They are radio network control plane, transport network control plane, and the user plane. And the layers available in this CS protocol architecture of IO interfaces: physical layer, transport network layer, and radio network layer. This is indicated in this diagram. Let us see the planes details individually in further slides. CS protocol architecture comprises of three planes. They are radio network control plane, transport network control plane, and user plane. In this further slides, we are going to discuss about these three planes in detail. IU interface CS protocol architecture. In UMTS, the interface between RAN and CN is IU. IUCS is the interface specified between the RAN, that is Radio Access Network, and the 3G MSC. The three planes in the IUCS interface share a common ATM, that is asynchronous transfer mode transport. Physical layer is the interface to the physical medium such optical fiber, radio link, and copper cable. Now we see the control plane information of CS protocol architecture of IU interface. Control plane. Control plane protocol stack consists of RANAP on the top of the broadband BB SS7, that is Signaling System 7 protocols. The applicable layers are Signaling Connection Control Part SCCP, Message Transfer Part MTP3B, and SAAL SSI, that is signaling ATM adaptation layer for network to network interfaces. Radio network control plane representation available in the CS protocol architecture of IO interface is shown below. This is the portion of radio network control plane. The SAAL-NNI is further divided into service specific coordination function, that is SSCF, service specific connection oriented protocol SSCOP, ATM adaptation layer 5 AAL5 layers. The SSCF and SSCOP layers are designed for signaling transport in ATM networks and take care of signaling connection management. AAL5 is used for segmenting the data to ATM cells. Above the ATM layer, we have found an ATM adaptation layer AAL. The AAL processes the data from higher layers for ATM transmission. It can segment the data into 48-byte chunks and reassemble the original data frames on the receiving side. There are 5 different AALs. They are AAL0, AAL1, AAL2, AAL3 or 4 and AAL5. Among that, IU interface uses only AAL2 and AAL5. Both are used in IUCS interface. Now we discuss the transport network plane available in the circuit switched protocol architecture in the IU interface. The transport network control plane carries information for the control of transport network used within UCN. Transport network control plane protocol stack consists of signaling protocol on top of BBSS7 protocols for setting up AAL2 connection, that is Q2630.1, adaptation layer, that is Q2150.1, that is AAL2 signaling transport converter for MTP3B. Transport network control plane representation of CS protocol architecture in IO interface is shown below. This is the representation of transport network control plane portion of CS protocol architecture. Now we discuss the user plane information of circuit switched domain protocol architecture of IU interface. The user plane carries user voice and packet data information. A dedicated AAL2 connection is reserved for each individual CS service. In IU CS interface, user plane protocol residing directly on top of AAL2. User plane representation of CS protocol architecture in IO interface is shown below. This is the user plane portion that is present in circuit switched domain protocol architecture of IO interface. AAL2 is used as the data bearer. AAL2 has been specifically designed to transport short length packets. The AAL2 is used for the following services. They are narrowband speech, unrestricted digital information service, and any low to average bit rate CS service. CS domain and PS domain representation is shown below. Here is a representation. The mobile station is connected to the access network. The access network in being connected to the core network. The core network comprises of two domains. One is PS domain, packet switched domain, and the another one is CS domain, that is circuit switched domain. The PS domain is responsible for the internet purpose, and CS domain is responsible for circuit switched network, that is voice oriented network is being performed in CS domain, and data oriented services is being done in PS domain. 2G GSM/GPRS and 3G UMTS blocks comparison is shown below. Here is the representation. In the 2G, that is GSM GPRS network, the blocks available are the user is mobile phone, the radio network in the 2G is BTS and BSC, and in the core network we will be having MSC/VLR and we will be having GMSC. This is being connected to the PSTN in the external network side. These are the blocks that are available in the 2G GSM GPRS. Now, if we look into the 3G UMTS, means we have mobile phone. The user is the mobile phone, and the radio network part comprises of node B. The node B is in turn connected to the RNC, that is the radio network controller. These two blocks represents the radio network in 3G UMTS. In the core network of the 3G UMTS, we will be having SGSN and GGSN. These blocks in turn connected to the data networks. Example, internet. Maximum this EIR and HLR and authentication center is common for the both 2G as well as 3G networks. This is the representation comparison. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video, means you can share this video to your friends.